Hi there. So this week we're going to talk about misleading graphs. Last week we talked about different influencing factors that might give different data. But today we're going to be talking about how once you've got that data, there are different ways that people represent things to sometimes try to trick people into thinking something might be a certain way when really maybe the data doesn't show us that. So I've picked out some different graphs for us to look at and show you how people do this. With the first one, the most common trick that you're going to see people use is that they don't start the scale at 0. So you can see here, I've got my mouse pointing at this y-axis, and you can see here that this is 5,175 is where it starts. So what happens when you do that is it makes the gap between the lowest one and the highest one look much larger. So here, it makes it look like it's a great big drop. Another trick that people use is that, so again, this is actually, the same trick, but it's just, they use this trick with line data as well. So in a bar graph, you can see that they represented it that way, but here as well, this makes it look like this peak is way bigger than where it started, when really it's only 2.5 times, but it makes it look like it's even 7 times higher. This next one is a misleading graph where they've drawn it with a picture. So sometimes we call this a pictograph, sometimes we call it a picture graph. Basically what is happening here is that what they really are trying to tell you is that Shayna had somewhere between 16 and 20, so probably like 18 Halloween candies. And over here, they're saying that Michael had 36 Halloween candies when you transfer the and trace the line back here. But if you look at how many of these little candies would fit in there, it looks like way more than that. The picture shows it that it's like 3 times more, but really it's only double. So you can see that by making these pictures the way that they do, the area is much, much bigger than it should be. And it misleads people into thinking that really Michael has way more candy than he does. Michael really only has double the candy. The picture looks like it's triple. Some things that I like to ask myself whenever I'm looking at a graph is, what are they trying to show? So the best way to look at that is to go and find the title, and that's usually what they're trying to represent. And then I like to see sort of what that graph proves. So I like to kind of check and see, okay, well, what are they trying to say here with this information? Then I ask myself, are they using any of these misleading tricks? And then I always like to kind of think about why they might be trying to use these tricks. So is it like, normally it's because they want to prove their point, but what is their point and why are they trying to figure that out, say that? So those are the 3 questions I find are helpful to kind of revisit every time you are looking at a graph. So I've got some different ones here to show you. So this first one is talking about pizza, hot dogs, and hamburgers. In this graph, you can see they put the title at the bottom, which typically isn't our favorite thing to do. So it would be better if they had a nice title here, but the title should really be that these graphs represent people's favorite foods. And the graph on the left, if I look at this scenario, we've got pizza, hot dogs, and hamburgers. What does it make it look like? You can shout it out at your screen. For me, it makes it look like, I really think that it looks like hot dogs are just the clear winner. They're way more popular than pizza or hamburgers. So that would be the impression I get from the first graph. But if you look at where these numbers started, along this y-axis, this one starts at 950. So it doesn't start at 0. And that's the trick they've used here to make it look like hot dogs are the winner. If you did start your graph at 0, you'd get graph 2 over here. And graph 2, if you started at 0, you can see that actually these are pretty even, right? They're not, hot dogs isn't really running away with it. But graph 1 really makes it look like hot dogs are the most popular. So again, if I go back to kind of thinking about my questions, if I were to think of who might give me graph one, maybe if I was a hot dog manufacturer or if I was really trying to sell hot dogs, I would be saying that graph one would be the best way to represent the data, but really it's pretty misleading. Graph two is the best way to represent the information if you want to be fair about it, and graph one would be the misleading way to do so. Okay, I have another one for you. Here is another one. With this one, this was a score on a computation test. So this would be like your percentages. And here we've got Danielle, Jared, and Alexi. So it looks like Danielle has about like 97%, and Jared looks like just under 96. Same with Alexi here. What would be the misleading trick that they're using in this case? Yell it out. If you yelled that it's not starting at 0 along this scale, I think that that is a great answer. And if you didn't yell that out, then maybe you had some reason that it was misleading. But for me, that would be the big one. What I'm noticing is that this was probably put together by this graph. If I was to predict who made it, I think Danielle put it together, because Danielle looks like she's way above the rest when really she's only like a percentage higher in her score. But she made it look like she was well ahead of the game. So I would say that this graph was put together by Danielle if it was me, if I was a betting person, because she looks like she's way ahead of the game. All right, next up. So this one is asking, or this graph, if I read the title, it says the United States is producing more trash. So they're putting what they're trying to prove right in the title. When I look at this, along the side here, it's got millions of tons of trash. This is 100, that's 200. They're saying that in 1960, there were 80 million tons. And in 1980, there were 160 million tons. So really clearly, we can see that it's doubled, right? If we had 80 million and then now 160, it's just twice as big. But if I look at this garbage can, it looks like I could almost fit 4 of them in there, 3 or 4 of them at least. So they've really been quite misleading when they've drawn it this way. It makes it look like it's just way bigger in 1980. It is bigger, it's double, but it's not that much bigger. So we want to always be fair when we're drawing our graphs out. Here's another example. This example over here is the improper scaling. So this is what I was talking about when I was when I was giving examples of these pictographs where they've just made it so much bigger. The problem with this first one, this improper graph, is that it looks like you could fit a whole bunch of those little people in there, right? Almost like 9 of them probably. A better way to draw this, the regular way that you would want to draw a pictograph, is instead to show them sort of stacked so that each person is represented by one little item, and you can stack them in a tower and make it much more clear that you really just mean that it's triple. Here's another way to show that information. So here you can see that if you left this graph like with the improper scaling, you can see that you've got 9 little people that are filled in there. And really it should only be triple. So that's this over here on the right hand side of the screen is really why we don't want to draw something scaled up like that. It makes it look like it's way bigger when in fact it's only triple. Okay, I have one more for you. Here's this last one. This has 2 different graphs with it. Let's first talk about this one here. So with this one has 1998 and 1999, and along the side it says the average house price, and then the years are along the bottom. So if I were to bet, I would say that somebody who was trying to prove that the house prices went way up was drawing this graph. They didn't start at 0. And because they didn't start at 0, it's really misleading. It makes it look like 1999 was a huge jump when really the house prices only went up 2,000. And then the other graph over here on the right-hand side, this one makes it look like in 1998, the number of houses sold was super tiny, but it's really the perspective that you see. It, whenever somebody draws something and then kind of tilts it or makes it skews the view or the perspective of it, you always are getting kind of a misleading graph. It would be much better if we saw that bar graph head on, like the one here. This one's still misleading because it didn't start at 0, but at least with the problem with this one is that the perspective is just totally off, and so it really messes it up and it makes it hard to compare them. Really, 1998 only looks like maybe it's halfway down on 1995 if we were to put this back to just face it head on. But when you look at it sideways, it almost looks like it's a third of the number of houses, but it's probably more like half. So my hope is that by looking at those, you can see what I'm talking about when I'm talking about misleading graphs. We're going to ask you to do some questions on CrowdMark to check that you know this stuff. But from now on, when you look at a graph, I would really try to see, is it misleading and why might it be misleading? Chances are you're going to find that a lot of graphs are actually drawn in pretty misleading ways to always try to convince you of things. So just keep your eyes out for those graphs and make sure that you're being critical of how they're graphing and showing you that information. Take care.